just like to thank everybody for coming back again for another session. In this session, we have J.Bragg with us. Joshua's been involved in almost all the iMoots, I think, maybe. But I love the title of this one, Using Question Statistics to Keep Your Multiple Choice from Sucking. So very much looking forward to this. Thank you for your time, Joshua, and I'll hand it over to you.
When I picked the title of this, I was mostly just going for something fun. If anybody's terribly offended, I'm sorry. I kind of like it, so we're just going to go with it. I'm a high school chemistry teacher for the most part, and also the Moodle administrator and the Moodle trainer for my school. And so I'm kind of in a lot of different roles. So being a high school teacher, though, I'm very highly dependent on seeing people's faces when I talk, and so it's always a little disconcerting to talk online. So if you guys would please just feel free to comment and say anything you like at any point in the chat. Feel free to jump on the mic and ask questions in the middle of whatever it is I'm saying. I very much like to talk with you guys and figure out what's going on and what you're thinking along the way, so that we can kind of modify things as we need to. I got the idea of this this presentation from just kind of watching people use multiple choice over the years. I think we've all kind of seen some examples of some not so great multiple choice along the way. If you have a minute to pull up in another tab a Moodle course and a Moodle quiz that you got access to as a teacher, so you can see the statistics that we're talking about on a course you're familiar with. If it's one of your courses, great. If it's somebody else's course, that's fine too. Just might be helpful to see something on a little bit more personal level, just so you guys have more of a sense of what's going on. But we've all kind of seen really awful multiple choice. I mean, multiple choice gets a really kind of horrible rap just because, I mean, really, you can do it really horribly. I mean, here's a not terribly uncommon example of that. If you're looking at this question here on the screen, it's, you know, if you're looking at this as someone who doesn't really know anything, at the end of the day, probably sees the right answer. It's the longest one of the bunch. It's the one that's not like really in any of the others. And then I'm giving you this big giant clue down here with D at the bottom, which no reasonable person is going to put that on there. And yet people do this sort of thing all the time on their multiple choice, where they're just kind of taking some of the power away of people picking choices that are good for students. And so, yeah, Teresa, I'm Santa too, at my school in this case. Right, exactly. That's Miranda. You nailed it. I mean, there have been more than one occasions where you can, if you don't know anything, you can just kind of go through and click and get a pretty good score. I used to say when I was in high school that you could drop me in on somebody's multiple choice test most of the time, and I could at least make a C on that test without even really having to really think too hard about it. But the good news is that Moodle actually builds in all of the stuff that you need to do to make sure that that doesn't really happen. This presentation is going to use a bunch of questions where all of the questions are from the Release North Carolina final exam for chemistry. So this is a high school level test. I put it in my Moodle course as just a practice test for students to do. They're doing it actually right now during exam review. And so fundamentally, this is a really good example of the way things are supposed to look like. I've kind of picked questions where the statistics look the way that they should, so that you see how they're supposed to work. I've got some rougher examples in there along the way so that you can see some things too. But this is kind of fundamentally a good example because I want you guys to see the way that it is kind of supposed to work. So the way that you get to these statistics is in the quiz itself. In the administration panel, there's the results, and most people just kind of click on the results, and then it takes them to the results, and they're kind of happy with it. They see scores and all this sort of thing. But then there's this drop down menu that happens when you open that up, and in there, kind of buried in there, is the statistics. And when you click on that, you get an enormous array of statistics. And so I'm a chemistry person and I'm kind of used to statistics and math and all this stuff. So if I start talking way over your head, please stop me. I'm going to assume that y'all have seen a lot of some of this stuff along the way, but I realize also some of this stuff is unless you're paying attention to item analysis sort of thing on a regular basis, this is not something that you would have seen before. Carrie, it's okay. Don't worry about it. I'm really mostly a chemistry teacher because I like to light things on fire and blow things up. And it was just kind of fun along the way. Don't worry about the chemistry. There's not going to be a whole lot of chemistry that actually shows up in here. Yeah, so since this has already come up, I'm just going to have to go ahead and show you guys my last slide. That's me. I really do like lighting things on fire. It's really pretty amazing. So anyway, this is the first kind of bit of that report that you'll see. And so this is just kind of some basic statistics. How many people have attempted it? What is the grade on all of the attempts? I've opened it up. I've opened it up so people can take it multiple times, and so you can see that in there. And so this is showing you kind of the average score on each of the attempts, along with the median score. So just a quick show of hands. And so is everybody familiar with the hand function on the on Big Blue Button? There's, if you look on the left-hand side there in the user menu, there's a little hand icon, and you can click raise hand, and it'll pop up a little hand like this over here if you look next to mine. So just kind of a quick show of hands. How many of you are familiar with the difference between an average score and a median score for a test? Miriam, I like the face there. That's a good. Okay, great. Well, this is so. Let's just kind of pop through that real quick, just so that everybody's familiar on this. So this is the average or the mean is something that is kind of just like the normal sort of average that you do. You take all of the grades up and you divide it by the number of scores that you have. That's really fairly useful for the most part, but as is the case a lot of times with quizzes and tests, there are sometimes very low scores that drag down the average more than it really should be. This is the same sort of thing that happens with home prices as well. And so what you'll often see when people talk about home prices, at least in the US, I'm not sure if this is true elsewhere, but they talk about the median home price in an area. And so the median grade or the median home price is you take a listing of all of the different scores or all of the different home prices, and you find the score or the home price that is in the middle of the list. Now, if you'll notice here, the median score for this, for the first attempt, is 74%, whereas the average is 71. So that's, again, another example of kind of these lower scores dragging down the average. And so the median is something that you interpret as half of the students are making better than a 74, and half of them are making less than a 74. The next kind of important statistic here along the way is the standard deviation. So standard deviation tells you how much spread is there in the data. So if you think about a bell curve, a standard deviation on either side of the average is going to give you 63% of the scores. So what we're saying here is if we take that standard deviation of 22 and we compare it with the average of 71, that means that 63% of the scores that students got are going to be in between a 93 and a 49, which is a pretty big range here. Now, that is actually fairly atypical for most teacher tests. The reason why this one is so large is because this is released.
This is really bad. Oh no, it's not a headset.
This is released standardized. This is a released standardized test, and so this is designed to separate out students a lot. Most people want good, sort of reasonable grades, and so most people's standard deviations are much lower than that. Mine typically on my tests run somewhere in the neighborhood of about 15%. the statistics here that we really need to talk about the most, that matter the most in terms of designing a good quality test, are these last three down here. So those are your coefficient of internal consistency, which for those of you who are know a little bit about stats, that's the same thing as Cronbach's alpha. The error ratio and the standard error. So we're going to talk just a little bit about each one of these along the way here so that you understand what it is these numbers you're looking at are. Coefficient of internal consistency is measuring how well does the test the same sort of thing. So when I write a chemistry test, I want that to be a test of chemistry. I don't want it to be a test of chemistry and calculus at the same time. There's no reason for that to be a thing unless I'm actually teaching calculus and chemistry at the same time. So if different parts of the test are measuring different things, then they won't necessarily go together. And so what the coefficient of internal consistency does is it tells you how well all the questions on the test essentially correlate with the final answer with the final score of the test. And so essentially this is a measure of how reliable the test is. You want this number to be as high as possible. You are never going to get 100% on a test, but you can try to get as close as you can. Getting up to 90% is amazing. This is usually things that you only find with standardized tests that have been run through a bunch of iterations to make sure that they do well. A lot of teacher tests, if you're doing fairly well, if you can get a coefficient of internal consistency somewhere in the 70s, that actually works out fairly well. If you start going lower than that, then you start having problems. The next two numbers kind of tell you what those problems look like. So the error ratio talks about how much of the standard deviation is due to random effects versus the student's ability. So remember, the standard deviation that we talked about before was how much spread is there in the data. So how much of the spread in student scores is based on the students of different ability levels, because we know the students are different from each other and are going to have different ability levels, and how much of it is due essentially to the test itself. And so in this case, on this particular one, we see that the error ratio here is 28%. So 28% of our standard deviation is due to essentially random effects that we are not sure what they are, not due to student ability. Which is, you know, it seems kind of high, but it's also, in the grand scheme of things, that's actually fairly low for most things. Miranda, when you're talking about the system, what system are you referring to? So Maureen, what you're looking at to do these sorts of calculations is you're comparing the individual questions and how well each question correlates with the final score on the test. And so at the end of the day, a lot of this, and so Miranda, this is kind of getting to your question too. A lot of this is essentially done in item analysis theory and statistics. And so there's a certain amount of scores that are, there's a certain amount of math that kind of goes into where all of this stuff is coming from. And so it essentially boils down to how well are those individual questions correlated with the overall score. So Eric, in this case, it is not a take once only test, and so that does affect things. And so if you'll notice here, I have limited all of the statistics run on this to the first attempts only, just to make sure that that everything is kind of the way that it should be. So yeah, Mary, that's when you look at an error ratio of 55%, what that's not necessarily saying that that a lot of people are guessing. What that may mean is that you've got questions that are bad, and some of the bad questions are making it difficult for students who know the material to get the correct answers. Or on the reverse side, you've got questions that are bad that are helping students figure out the answers that they don't necessarily know it. Yeah, Dorothy. Yes, it's actually not so much Moodle that says trust me. It's the statisticians that are saying trust me on this. And to a certain extent, I know what the math. I've done the math once upon a time, but it's long since ago buried on kind of where that is. So let's kind of skip ahead to this standard error number. So the standard error number is how much, based on that error ratio, based on the internal consistency, how much is a student's grade likely to change if they take it again? So Mary is saying here her standard error is 10%, which means that student scores, if they take it again, if they have learned nothing else new, their grades could vary by as much as 10%. So for me, that's a letter grade that it could vary. And that's a letter grade plus or minus in every direction. So a student who ends up with a 85, a B in our scale, could really be at a 95, or they could be at a 75. And we can't really be sure where their true ability is in that range. So we can be, so the math here is we can be essentially 95% sure that they're somewhere in that. Actually, let me take that back. One standard error would be 63% sure that they're somewhere in that range. But we can't be very sure that they are not outside of that range along the way. And so when you look at standard errors that are that large, the question becomes, well, is this a function of the test, or is this a function of something else? And very often it's a function of the test. So let's take a look at kind of how you start to figure those details out. And the next piece down underneath this is the individual item level statistics. Now, here we get into a whole bunch of other things that are mostly useful, but some things that we're going to just kind of ignore for now for the sake of a short session that we're going to go for. So I'm going to pull up just kind of this first row here and talk through some of the more important pieces of this. So the facility index is a very fancy way of saying essentially the percent correct under most circumstances. The Moodle math is essentially good enough here to deal with partial credit and handle that correctly, as well as handling certainty-based marking and all sorts of other things. And so they say the facility index here because saying percent correct would not be technically correct in some of those other options. But if you want to just say facility index is percent correct, that's close enough for what we're doing here. The most important numbers are the two numbers back at the very end back here, the discrimination index and the discrimination efficiency. And to a certain extent, these numbers are saying the same thing. This is now the same thing we were talking about earlier. So Eric, no, this is not necessarily for multiple choice questions. The same rules apply for all of the other question types. It would have to be something that's automatically graded. And I'm not sure that every question type can do all of these different statistics. I think that's dependent on the question type itself. I'm not entirely sure on that. But certainly you can do this for short answer. I use it for short answer quite a bit. Calculated questions, that sort of thing along the way. So the discrimination index is how well is this student's score on this one question correlated with their overall score on the entire assessment. So now we're going back to those pieces that fed into that coefficient of internal consistency from before. The bigger the number, the better here. What this is saying is, how well does this one question predict the score on the exam at the end? What we don't want is for us to give a question on a test and that not to be predictive of how a student is going to do on the entire test. We certainly don't want what would be a negative discrimination index here. A negative discrimination index would say that the best students are more likely to get this question wrong, and the worst students are more likely to get this question right. So as generally speaking, as high as you can get this number, the better off you are. But at the end of the day, the discrimination index is limited by how easy or how hard the question is. So when you're designing a multiple choice test that's a standardized test, you're trying to spread out students kind of as much as possible along the way. The so you have a range of questions that kind of at your disposal, some of which are going to distinguish the essentially the smartest students from each other, and some which are going to distinguish the less smart students from each other. The discrimination index is essentially saying, well, how well are we doing at that? But if you have a question that's designed to tell apart the top 5% of students from each other and say only the top 2% are going to be likely to get this question correct, then that's going to be a question that most people miss. And so at a certain point, that doesn't help you distinguish the students at the bottom end of the scale from each other. It's there and it's a useful question to distinguish the top students from each other, but it's not a useful question to distinguish the bottom end students from each other. And so for a question like that, the discrimination index is going to be essentially artificially low, even though it may be serving a useful purpose. This is where the discrimination efficiency statistic comes in. This helps you better tell, based on how hard or how easy the item is, how well things are doing at a discrimination level there. And so you'll notice this particular question is a very easy question. 87% of the students got it right. And you see that the discrimination index is pretty good. Getting close to 50% for a discrimination index is great. But it's actually fairly limited it's limited along the way because of this 87%. This is really only going to be good at telling the students at the bottom end from the students through most of the rest of the group. And so you'll see the discrimination efficiency is much higher than the discrimination index, because now we're accounting for the fact that this is a pretty easy question in the first place. So yes, Eric, these numbers do change over time along the way with every new score that gets added in this. And yet, Miriam, you are right. When it is completely random, when it's random questions over a big, gigantic range of categories, you're right, it doesn't work nearly as well. It tends to show just a small subset of them. If you can get a quiz where where you're picking, say, 2 questions out of this one small category and not all the subcategories underneath it, then you'll see a listing of all the questions in there. And so, Miriam, the other potential there is that some of the questions in that group can't be analyzed, or there's also some problem with the math run on those because of the way that the numbers are being done. And I remember reading in the docs that that's a possibility, and I don't remember off the top of my head what the situation is like that. But I'll see if I can find that for you later. So, Eric, going back to what you were saying earlier about this changing over time, I actually got myself in a little bit of a spot making this presentation, because some of the stats were changing as I was working on this particular presentation and as students were taking it, and so it's it's kind of you kind of be a little bit careful with it along the way. I probably ought to have closed it off, but students needed to study. Miriam, if you look further underneath that random question from X category, it should show you at least 3 that have, thanks for stopping by, Mary. If you look under the random question thing, that should say underneath that 3 different ones of a low facility, a medium facility, and a high facility, which will kind of give you some examples in the range of what it would look like. And that's what that's showing there when it looks at that. So one of the things that you hopefully don't see in your report if you're looking at one, but very frequently you do see, is a question name that's highlighted in red like this one. What that means is that your discrimination index is very low, I believe under 10%, or possibly negative. And so this is saying this question does not do a good job at all of distinguishing students from each other. It cannot tell who the best students are from the worst students. In the case of a negative discrimination index, it may even be doing the opposite of what you want it to do. It may be rewarding the worst students and penalizing the best students. most of this discrimination index effect comes from the answer choices themselves. And so this is the question that I showed you earlier that had that bad discrimination index. Now, y'all probably don't. We've already had some objections to seeing chemistry before. And so I'm not expecting you guys to be able to look at this and say, well, what's wrong with this question? Is there anything wrong with this question? So let me just tell you from a chemistry teacher's perspective about this question. When I looked at this one, I said, there's nothing wrong with this question. All of these answer choices are correct. Every single one of these is one that is likely for students to pick. The least likely is the one that I was expecting, that would be the lead oxide that nobody picked. The interesting piece here is this is one of those topics that tends to be something that most of my students are pretty automatic with at this point. And I started looking at, well, why is this one not so great at discriminating students? So I started looking at the students who had missed this question and the students who, and actually their individual attempts. And what I found is that order matters quite a lot when you're looking at multiple choice questions, which we know, right? We all tend to like to put a wrong answer first when we're making a multiple choice question, which is why A is very frequently one of the least used responses on personally made multiple choice questions. And what I was seeing is that anytime or frequently when this lead dioxide answer was above lead 4 oxide in the answer choices, it was much more likely to get picked because a student reads through and says, oh, it's that one, clicks it, moves on, doesn't bother reading the rest of the answer choices on there. And invariably, when I have students that come in and look at something like this, they look at it and say, oh my goodness, I can't believe I did that. So going back to Eric's question about the discrimination index changing over course of time, this is one of those that it did change. At last check, the discrimination index on this one was hovering around 12%. So it's gone up a little bit, but not very much. And it's mostly the same sort of effect along the way. When you've got people who are essentially picking the first one that they see that looks good, then that essentially is going to mess up all of your results there along the way in terms of being able to predict scores off of this. So here's another question that's actually from a different source. So this is not one of the released items. This is from another question bank that I happened to pick up along the way. And so this is the different answer choices here, the questions up there at the top. Again, I don't expect you guys to know the chemistry. The important thing to notice here is the correct answer, nobody picked, which is super. I mean, the discrimination index on this one, if I remember correctly, was like -70 something, which is clearly awful, and we can see why. If nobody's getting this question right, and there's a lot of people picking this one for some reason. And then I noticed, I didn't write this question, but if you look here, the actual electron configuration for X, so X in this case is fluorine, should be, instead of this N right here, should be an H. It should be helium instead of neon. And then the other little subtle thing that they did was change this. This should be 2s2, not 2p2. And so this is really very much a gotcha question of you've put in something that is designed to trick students, and it is tricking students effectively. Students read through this, it looks very, very similar to what they're expecting it to be, and choose that answer as the correct answer. A lot of those students probably never even noticed that that was not exactly an H instead of an N and a P instead of an S. They just went and picked that one because that's what it looked good. Yeah, so and the second one is the correct answer here. That is the correct answer. That's the one that they should have picked. And so the first one up there is is actually a pretty common mistake for people. The 2p5 here makes people think that there are 5 valence electrons along the way. And then the 4 valence orbitals with all opposite spins is another subtle little tweak on things, and that's actually not a bad answer choice there. And so if I were getting into the psychology of a student here, looking at this sort of thing, notice here, this is an ion that's X minus, and so that means it has an extra electron. So if you look at the correct answer here, it's helium 2s2 2p6. And so, Vinny, I apologize that these aren't superscripted. It messed it up in the response table. I know he's sitting over there cringing along the way. Vinny used to be a chemistry teacher, so he's probably over there cringing in a corner right now. But looking at this one here, the neutral atom doesn't have that extra electron on it, and so they were expecting a neutral atom and to come out as being 2s2 2p5, and because this is an X minus ion, if they didn't notice that, then they would not choose that because it's not exactly what they're expecting it to be. Does that make sense to you, Anne? And so, yeah, I'm using chemistry here because it's something I can easily talk about. Unfortunately, I could make up things and have students take random sorts of things that are going to make more sense to everybody, but then they don't. Then you get weird statistics along the way because students aren't really trying. My point here in talking about both of those questions is that good distractors. So Eric, yes, that was a bad question. This is a bad question here because students are picking things for essentially the wrong reasons. You've got a gotcha question here on an answer choice that should not have been in there like that. Basically, you were testing the student's reading ability as opposed to their chemistry knowledge. So here's my big point here on the discrimination index is that good distractors are really the key difference between good multiple choice questions and bad multiple choice questions. So here are 2 questions with the exact same question, the exact same correct answer, and yet what these questions test is wildly different from each other. The first question is really testing, do you know the decade that World War II ended? The last question is testing, do you know the actual year that World War II ended? And that is all a function of what are the wrong answer choices that you put down there. So if you're looking at a bad multiple choice question based on the discrimination index, one of the first places you start looking is at the distractors. Make sure that the distractors are there in a way that is, number one, not playing games with the student, but number two, making sure that they are good possibilities for the way things are actually going to work. So I've got one more example, and this is actually from that released exam. This is the responses to another question. And so you can see here that the students, none of the 30 students that took this test when I pulled these stats had picked either of these 2 options. Eric, yeah, you have a point there. So this is one of those situations where these are essentially wasted distractors. No one is picking these. There is no reason to have these on this test. You're not gaining anything by having these. Essentially, this is a true-false question with the way that it's actually being treated by students. They're reading this and saying, oh, those are not right. In fact, if I read this, the reaction is either going to be exothermic or endothermic. Those are really the only 2 options here. And so it's got to be one of those 2. So when you see a question like this, where there are responses that not many students are picking or no students are picking, that's a chance to start rewriting that distractor to put in something that students are more likely to pick, because if you put in something that students are more likely to pick, then you're going to get a better sense of how well students are actually doing in terms of their understanding the material. At the end of the day, all we really want is for our tests to tell us how well a student is doing. It's there to help us figure things out about the student. Well, if the test is not doing a good job at measuring how well the student knows the material, then it's time to work on the test. So this is kind of my process for how I look at multiple choice questions when they show up in my class. This is how I find things that need to be fixed and things that need to be tweaked. And so that's really all I have for you. Although I do have again the snazzy picture with all the fire. So if you guys have any questions or any thoughts or comments along the way, please feel free to jump on the mic or ask any questions that you have about anything that you've got. Yeah, and I really do I do a lot of random answers in my quizzes. I do tend to organize my question bank very specifically. So I am pulling questions from, say I want to have a question on doing an empirical formula, and then doing another one with an empirical formula of a hydrate, and another one with a molecular formula. Then at that point, I have it broken down into very specific question banks that I'm pulling from so that I can see the stats along the way. So, and you got a great question there. Is that fair? And so these statistics will help you answer that question. Because if you have a question, one question out of the bunch that's a bad question, you'll see it in the discrimination index. You'll also be able to see, is there one question that is substantially harder than another? Probably for some reason you don't even realize why it's harder than another. But the statistics there on the facility index will help you figure that out. Glad you found it useful, Maureen, and Michelle too. Yeah, Dorothy, I'm always well aware of the chemistry, the chemistry possibilities on this. Being a chemistry teacher, I get one of two responses when I tell people I'm a chemistry teacher. It's usually, oh wow, I loved chemistry. I had a really great teacher, or oh my goodness, I don't remember anything from chemistry. I want to block that out of my memory. Yeah, Dorothy, I like to think that I'm a good chemistry teacher. Carrie, maybe Carrie, maybe come visit my classroom sometime. I will light things on fire for you and make you fall in love with it real quick. I'm in North Carolina, so if you're never in the neighborhood, no, I have my own fire extinguisher. I will put out my own fires if I need to.
Folks, could you join me in thanking Joshua very much for a fantastic presentation? Joshua, personally, I have struggled with maths and chemistry, and that was a really awesome presentation. So thank you very much for sharing these ideas with us. I'm going to have to rewatch it again to take all of them on board. Thank you very much for joining us all at iMoot, folks.
Thanks, Lindy. So Eric, let me go back to that question so that I can answer you a little bit better. So the subtlety, and so this is really a chemistry point here that is that's the problem. So the correct answer, so if I were to modify this answer choice here to be the correct answer, what I would have to do is change the N to an H and change this P right here to an S. And so it looks very similar to what a student is expecting to see as the correct answer. They would expect to see an HE in brackets 2S2, 2P5. And instead, they're getting an NE in brackets 2P2, 2P5. If a student doesn't look closely at that, they're so used to reading these things that they just kind of interpret what it's supposed to be and then pick that answer choice along the way. Essentially, this was written so that it sort of looks like it's a typo to somebody who even maybe is paying attention, and then students will kind of pick it anyway. That's not testing chemistry. That's testing how well are you paying attention to this trick question, essentially, that we're putting on here. And that's not really the goal. And this is the reason why this question did not correlate with the rest of what was going on. A student who scores very, very well on this test may not have gotten this question right just because they didn't read it carefully enough. Whereas another student who didn't score as well as the other maybe did, well, actually nobody got this question right, but it potentially would have gotten this question right because they did read carefully. And so if you're not testing the understanding of chemistry, then the discrimination is going to, the discrimination index is going to look pretty awful. And so that's what you see coming out of that discrimination index. Does that make more sense to you, Eric? Agreed, Anne, but at the end of the day, the goal of a chemistry test is to test the chemistry. And so we have tests to test reading ability. And my goal in writing a test is, if I want to test reading ability, then testing reading ability is perfectly acceptable. And if, to a certain extent, I'm very much a fan of putting things in front of students and then pointing out when they don't pay attention to things closely enough along the way. But at the end of the day, on a summative test where I'm trying to evaluate how much chemistry my students have learned, I don't really like this question because it's not testing how well they know the chemistry as much as it is as much as they would have gotten the as much as they've just testing their reading ability. Eric, I'm actually kind of flabbergasted that nobody got this question right either. This is one of those where it even took me a second with it's one of those, so these are called electron configurations. When you start reading electron configurations, they just kind of become second nature, and little small things that are wrong with them you can't even see. I actually make most of my students do the practice assignments on these, where they type in their answers to these electron configurations, and they can be really these long things, and get a lot of emails from students saying, I'm pretty sure I have this question right. Moodle is saying it's wrong. Can you tell me what I've done wrong? And invariably what I end up doing is going through essentially character by character, looking for the small mistake they made somewhere that they can't see, because they're just kind of used to looking at it that way. And it's honestly, even for me, if I'm not going through character by character to look for things, it's hard for me to spot them sometimes, just because it all kind of blurs together really quickly. Well, thanks so much for you guys coming in. If y'all have any more questions, I'll hang around for a little bit. Feel free to ask. I really appreciate y'all stopping in and taking a listen. So. And there sort of is a graphical version of that to a certain extent. There is on the results page at the very bottom underneath the student scores, that there's essentially a distribution of scores, which sort of shows you the average and the standard deviation and the skew and kurtosis and all that sort of thing. But unfortunately, reading that off of a histogram isn't going to actually give you the numbers themselves. So what you could do is you could display some of those statistics on a graph, which is actually a pretty good idea. I would actually really appreciate that when I'm looking at it. I think I will make that suggestion to Tim Hunt as soon as I get a chance to. I'll do it, Anne.
Hi, this is Vinny from the iMoot team. I thought I'd just jump in and thank you once more, Josh, for presenting at iMoot16. Great presentation, and I love the chemistry. So I hope you all enjoyed it, and I hope everyone enjoys the rest of the iMoots.
All right, well, I'll see you guys around. I hope you guys have a good rest of the iMoot. So y'all have a good one. Hey, Eric, I'm glad you caught the video of that. I do a ton of quizzes, and so it's teaching tools is the place where I spend most of my time on using the quizzes to help actually teach concepts, because there's nothing like having a quiz that you can't kind of avoid getting feedback from along the way. So, well, y'all have a great rest of your day, whatever time of day it is. I'll hang around a little bit before I go to bed, and then and catch a few more presentations. But I'll see you guys around. Take care.
Cool. Thanks, Josh.